Today we're looking at some of the information from sample to sample variation and the difference of two sample means. So where is the center or the mean of the sampling distribution of x bar sub 1 minus x bar sub 2? Well, it's similar to what we saw when we were looking at the sampling distribution of just x bar. Now though, because we're looking for the difference, it will be mu sub 1 minus mu sub 2. The sampling distribution for x bar by itself was centered at mu. Here the sampling distribution or the mean will be centered at mu sub 1 minus mu sub 2. Now standard deviation will look similar, or you'll see remnants of what we saw with the sampling distribution of x bar. But here we'll have the square root, and then underneath that square root we'll have sigma sub 1 squared over n sub 1 plus sigma sub 2 squared over n sub 2. So the same characteristics apply to the sampling distribution as we saw for the sampling distribution of x bar. Whereas the sample size increases, standard deviation will decrease. Now remember, we've talked about in the past how we will not have information on sigma, because to have sigma you would have to know the whole population, and so we will have to substitute sigma with s, and that substitution will create a calculation called standard error of the sampling distribution of x bar sub 1 minus x bar sub 2. So for standard error, we still have the square root, but underneath that we will have s sub 1 squared over n sub 1 plus s sub 2 squared over n sub 2. So we'll use this information for sample to sample variation in the formulas for calculating confidence intervals and hypothesis tests. Now, something that is important for you to consider when we're starting our discussion of hypothesis testing is that now, because we're looking for the difference between two variables, the way that the differences are calculated between the two groups is going to impact how you will choose your null and alternative hypotheses. So you'll want to consider which group you expect to be the larger of the two and which you expect to be the smaller. And that choice will affect how you'll write your null and alternative. So for example, if I was interested in showing the average weight of dogs was greater than the average weight of cats, the way that I subtracted my differences would affect how my alternative would be written. So if dogs was going to be group 1 and cats was going to be group 2, and my differences were calculated dog minus cat, then my alternative, since I want to show that dogs are bigger than cats, would be mu1 is greater than mu2. However, if I had my differences being mu1 was cats and mu2 was dogs, then my alternative would be mu1 is less than mu2. So remember, if you're interested in direction for your research hypothesis, that would affect what mu1 and mu2 were and what the direction was in the alternative. Don't just assume because the problem says greater that would be the appropriate notation for the alternative, as it might be affected or changed depending on which is group 1 and which is group 2. If you do not care about direction, meaning that you're just looking for a difference, then you also aren't as interested in which is group 1 and which is group 2, simply in terms of writing the null and alternative.